So let's talk about energy flow, which really exists in food chains and food webs. And so I know you've seen those before. So let's focus this time on talking about the direction of the energy and the way the energy is moving. So we have a couple of words that we need to go through. So we've got organism types like autotrophs. Auto means self, troph means feeder. So autotrophs are organisms that make their own food or feed themselves, like plants. Heterotrophs, hetero means different, troph means to eat. So these are organisms that eat other things. So this is an organism that must get food from some other source. We also have some other words that we can use to describe kind of the same concepts, but with a little more nuance. We have producers, and those are organisms that make or produce their food, and those are autotrophs. We have consumers, and a consumer is an organism that eats or consumes its food, and this is also called a heterotroph. Consumers we can break down into different trophic levels. The 4 trophic levels that you need to know and be familiar with for this class are primary consumers, which eat producers, secondary consumers, which eat primary consumers, tertiary consumers, which eat secondary consumers, and quaternary consumers that eat tertiary consumers. And I'll give you an example of that here in just a minute. The last word that you need to know and not forget is decomposer. A decomposer is an organism that consumes dead organic material, and that's going to help with the recycling of organic molecules. Another way to frame this is the way that it's been framed to you earlier in your life. We have herbivores. Herb means plant, vor means to eat. So these are consumers that eat only producers. We also have carnivores. Carni means meat, vor means to eat. So these are consumers that eat only other consumers, no producers at all. Omnivores are consumers that eat both producers and other consumers. And detritivores, detrite means for detritus, which is the leftover materials on the ground that are decaying, and vor is to eat. So these are consumers that eat decomposing or dead organic material, such as fungus. We really wanted to focus this time on energy transfer, right? Because energy transfer is the major reason for interaction of organisms within an ecosystem. So organisms are going to pass energy from one to another, and we can do that through the process of feeding. And when 2 organisms are shown connected on a food chain, an arrow always points in the direction where the energy flows. So from the organism being eaten to the organism doing the eating. And that's a key point because that affects how you read all of the food chains and food webs in class from here on out. So here's a food chain example. I would copy at least one example of a food chain into your notes so that you have a good piece. So you can pause right here and do that. You want to notice that the energy is going to follow the arrows from the producer to the primary consumers, to the secondary consumers, to the tertiary consumers, to the quaternary consumers. So it's very important the direction that that arrow is pointing from the producers up through the levels. And you can see there where we have our herbivores labeled and our carnivores labeled. That's an important thing to be thinking about. So we're really talking about energy transfer. Different organisms belong to different trophic levels, right? And they belong to those different trophic levels based on what they eat and how far away they are from the producers. Many, many times when we represent food webs, food chains, and energy, we don't talk about the decomposers and scavengers, but they are incredibly important because they eat that dead material and they don't have to do any hunting. So very low cost lifestyle in terms of energy spent hunting. The energy is going to move through ecosystems, right? And so we can look at how energy moves using food chains, and food chains are going to show us a very simple energy flow. It's going to give us one pathway of energy. So from the grasses to the insects, to the frogs, to the owls, to the hawks. But food chains don't show us the whole picture in an ecosystem. And so for that, we have to use a food web. So here we can see that that hawk is not just going to eat one kind of creature, it's going to eat multiple kinds of creatures. And that way it's going to have a better chance of surviving as we go through. Right? The robins don't just eat one kind of material. If they did that, they would starve. So they need to have multiple kinds of things that they eat. And we represent that in a food web. So food webs are going to show us complex energy flow. They're going to give us multiple pathways of the energy through an ecosystem. And really what they are is a compilation of food chains so that we can see how they overlap and where they overlap. As you can see here, many creatures are going to exist in multiple trophic levels. They're going to exist in secondary and primary consumers, or they're going to exist as tertiary and secondary consumers. And I think that's important to remember. We know as humans, we sometimes eat producers and we sometimes eat consumers. But I think it's important to realize that other creatures in the animal kingdom do that as well. So don't forget about your decomposers. They are essential. Everything eventually gets decomposed, and that's what is responsible for the cycling of matter in a particular ecosystem. Food webs can be as complex as you want them to be. It just depends on how many organisms you include from a particular ecosystem. So this one's including more organisms, so we get more lines and more places to go. If you look at this particular food chain, you can also see the energy is displayed. And so if the sun provides 500,000 units of energy, then in that first trophic level, we're really only going to see 10,000 of those units captured. And in the second energy level, we're going to see 1,000 of those units captured, and then into 100 units, and then into 10. So it's getting increasingly smaller amounts of energy are getting up the food chain. We can display that this way. This is called an energy pyramid. Right? So much of the sun's energy is not used, and then after plants take their share, less is available for primary consumers, and then even less for secondary consumers, and so on and so forth. So another way to think about an energy pyramid is that this is reinforcing the idea that we can measure how much energy is in each trophic level, and that supports the idea that we're going to have fewer snakes than we do mice, and we're going to have fewer mice than we do grasshoppers, and we're going to have fewer grasshoppers than we do plants. And that's just on the basis of how much energy is included. So since there's less energy available further up the food chain, there's always going to be fewer top predators than prey they feed upon, or the top is going to run out of energy very quickly and crash. So if you want